All right, continuing with graphing y is equal to ax squared plus bx plus c. I already wrote out all the steps, but here's another example. So we're doing the exact same things that we did on the last example, but I'm going to go back and forth between this piece of paper and a piece of graph paper so I can graph things more accurately. Plus, it'll be easier to see like what certain mirrored points are. All right, but starting off with this equation, list a, b, and c. So a is a coefficient of x squared. That's 3. B is the coefficient of x, which is 6. And then C is the constant, or 2. Then the axis of symmetry, x equals the opposite of B over 2A. So the opposite of B is negative 6 over 2 times A, which is 3. Negative 6 over 6, x equals negative 1. Okay, and then I'm going to graph that on my piece of graph paper. X equals negative 1 is right here on the x-axis. It's always going to be a vertical line. So it looks like this. And like I said, the vertex should be on that line as well. So we'll come back to the graph. I'm just going to set it aside right now. Find the vertex. So the x-coordinate of the vertex is negative 1. The axis of symmetry and the vertex are always related. The axis of symmetry will always give you the x-coordinate of the vertex. So then to find the y-coordinate, I'm going back to this equation. Y is equal to 3 times x squared, so 3 times negative 1 squared, plus 6 times x, so 6 times negative 1, and then plus 2. Then do the math. Negative 1 squared is 1, times 3 is 3, 6 times negative 1 is negative 6, and then plus 2. 3 minus 6 is negative 3, plus 2 is negative 1. So when x is negative 1, y is negative 1. So then going back to my graph, because I want to now graph the axis of symmetry, even though I already did that, and the vertex. So the vertex is negative 1, negative 1. It's right here. If you remember the equation, y is equal to 3x squared. What was the rest? Plus 6x plus 2. A is positive 3. Since a is positive, I already know that the graph is going to open up. Okay? But then the next thing that we could do, so I already graphed the axis of symmetry and the vertex. It was just on my graph. The y-intercept is always 0, then c. So in this case, the y-intercept is 0, and then c is 2. 0, 2. So I'm going to put that on my graph. 0, 2 is right here. And then the next thing it says is find the mirrored point. I think it's going to be easier now, especially since I'm using graph paper to find the mirrored point. This is one space away on the right. So just go one space away on the left. There's another point. I don't even need to substitute in x equals negative 2 into the equation. If I substitute x as negative 2, I should get y as 2. Okay. And then I want to find 2 other points. Here's where I'm going to need to do some math. Okay. If you can, plug in x is equal to 1. That should be an easy number. I don't have a point where x is equal to 1 yet. So I'm going to let x equal to 1. I'm just not making a table, but I'm still picking a value for x. Somewhat easy to pick. I can't pick 0 because I already have that point. I can't pick negative 1. I already have that point as well. But when x is 1, y equals 3 times 1 squared plus 6 times 1 plus 2. 1 squared is 1 times 3 is 3. 6 times 1 is 6. And then plus 2, 9 plus 2 is 11. So when x is 1, y is 11. That's up here. And then that means since this is 2 spaces away to the right of the axis of symmetry, if I go 2 spaces away on the left, everything's symmetrical, and I can draw my parabola. Graph opens up. We know where the vertex is. The vertex is at negative 1, negative 1. The y-intercept is 0, 2. These would be the x-intercepts or the solutions, but that's what the graph would look like for the equation. Y equals 3x squared plus 6x plus 2.